Welcome to the third and final part of section 6.1 for Math 95. In this part, we're going to look at finding the domain of a rational expression. First, I want to remind you, what happens when the denominator of a fraction is 0? For instance, if I try to do 4 divided by 0. Back to its very definition, asking the question 4 divided by 0 is like asking the question, if I take 4 candy bars and I divide them up evenly amongst 0 children, how many candy bars does each child get? The question doesn't make sense. There were 0 children to begin with. We can't ask how many candy bars any of them got. 4 divided by 0 is similarly a nonsensical question. It just doesn't make sense, which means it really doesn't have an answer. We call this undefined in mathematics. So similarly, a rational expression is going to be undefined if the denominator is 0. So the domain of a rational expression or a rational function will be all real numbers except for the numbers that would make the denominator 0. Let's look at some examples to make sense of that. Here I have the expression f of x equals x plus 2 over x minus 2. Is there any number that you can see that is going to make the denominator be 0? Chances are you can tell just from looking at it that if x is 2, the denominator will be 0. I would have 2 plus 2 on top, which is 4, but 2 minus 2, which is 0, on the bottom. So the domain for this expression is x cannot equal 2, or all real numbers except 2. Those are both perfectly good ways of writing this down. Moving on to my second example, I have x squared minus 9 over 4. Now, is there any number that I could plug in for x that would make the bottom be 0? If you feel like this is a trick question, you're right. There's no way that I can plug in a number up here for x and get a 0 on the bottom of this function. So we're going to say that this domain is all real numbers. There are no problem points for this guy. Last up, I have a function that looks a little bit complicated, but I promise it's not that bad. Now remember, to find the domain, I'm trying to figure out what are the values of x that would cause the bottom to be 0. I can write that down mathematically by taking the bottom of my fraction here and setting it equal to 0. This looks like an equation that you know how to solve. We'll factor the x squared minus 5x plus 6, which gives us x minus 3, x minus 2. It's all set equal to 0, so to finish solving this, we set each factor equal to 0 and solve those little equations that result. This gives me the two numbers that x is not allowed to be. If I wanted to, I could even go back and write not equal to through my whole entire thing. So my final answer, the domain of this function, is x cannot be 3 or 2. Those are the 2 points that would cause a problem if I plugged them in here. If I plugged in a 3 or a 2 for x, I would end up with a 0 on the bottom, and division by 0 is undefined. And of course, I have 3 examples for you to try, so go ahead and pause the video and see if you can write down the domain of each of these rational expressions, and then play the video up and we'll talk about them together. And we're back. My first example was 4x plus 7 over x plus 1 times 4x minus 3, and I'm trying to find the domain. That means that I want to find all the values of x that would make the denominator 0 if I plugged them in. So I take my denominator and set it equal to 0, or maybe I'm thinking set it not equal to 0, since that's what it's not allowed to be. I've got two things being multiplied together to equal 0, which means that either the first one, x plus 1 is 0, or 4x minus 3 is 0. Then I can solve those little equations, and I end up with two values, -1 and 3/4, that x is not allowed to be. One way to say that is that the domain is x cannot equal -1 or 3/4. You can also write that down in words, all real numbers except -1 and 3/4. My second example was 5x over -x plus 3. Again, I'm trying to find the values of x that would make the denominator 0. So I took my denominator, -x plus 3, set it equal to 0, and then solved that equation. It gave me one value, 3, that x is not allowed to be. Because if I plugged a 3 back into the original equation, I would end up with a 0 on the denominator. and division by 0 was bad news. On my last example, I had 2x plus 6 over 3x squared minus x minus 4. Now again, my goal is to find the values of x that would make the denominator 0. So I start by just writing down that sentiment. I take the denominator, 3x squared minus x minus 4, set it equal to 0. Now I have an equation to solve. In this case, I have to factor first. I factored this guy to get 3x minus 4 times x plus 1. Now I take each factor and set it equal to 0, and then I solve the little equations that result. And that gave me 4/3 and negative 1. Now remember, those are the two numbers that x is not allowed to be. So I might write all numbers except negative 1 and 4/3. Or, like I did before, I might write x cannot equal 4/3 or negative 1. Finally, I sometimes find it helpful when I'm solving these problems to, instead of writing equals here, write not equals, so that when I get to the very bottom, I don't forget that these are the numbers I'm supposed to exclude. They're not really part of my answer. They're the part of my answer that I'm throwing out. Finally, to wrap up section 6.1, here's a summary of the 4 things that we did in this section. We've talked about how to find the domain of a rational expression. To do that, you find the values that make the denominator 0 and then exclude those, or write x does not equal those. To simplify a rational expression, we factored everything and then canceled whatever we could from the top and the bottom. To multiply two rational expressions, we factored and then multiplied straight across, and then finally simplified by canceling everything that we could. To divide two rational expressions was basically just like multiplying, except with the first step that you flip the second term, and then you multiply straight across. Before I leave you, I'd like you to notice how each of these skills builds on the other ones. To simplify a rational expression, we factored and then canceled. To multiply, we still had to factor, we multiplied straight across, but then we did the same thing that we had done before, simplified by canceling. To divide two rational expressions, we first flipped the second one, but then we went back and used a previously learned skill of multiply. I really encourage you to try to think about these skills as being interconnected. It's a lot easier to remember 3 interconnected things in your mind than it is to remember 3 things that are completely separate. The more you practice these skills, the more you'll see how interconnected they are. So go ahead and get started on your homework, and I'll see you in class.